Assalamualaikum and a very good day to all of you. So today, hopefully we can continue our class with another topic of project time constraint off, which is another topic for my part. Okay. So today we are going to look at on this topic for project time constraint off, or later on we just call it as project crashing. Okay. So I think without further delay, let me proceed to the class. With this class. Right. Okay. So as usual, this is our quick check because it is very, I think it's very essential so that this one can keep all of us on track. Okay. What topic that we have done, okay, what we are going to cover. So we will keep on checking on our progress, okay, for our topics for this class. All right. So for the lecture plan or topics that the rest that we need to cover, basically we have these three, including for this class, 1, 2, 3, three more topics. Previously, I have started my part since week 9, okay, up until last week, week 12. So there are three more topics for my part, which is the last part for this class, okay. Since this class has been divided for Mr. Rahim Pans and my part, right? Okay, for today we are going to cover on this one, as I mentioned just now, which is basically on week 13 right now. Okay, so that's regarding the topics. And about the assessment, okay, I already mentioned about this mark distribution several times. So hopefully all of you already clear, okay, how many percentage or how many total marks that contributes for my part and also Mr. Rahim part. So far we have done this because I have give the assignment, individual assignment to basically for week 12. Okay, so today we will have another individual assignment 3. I think basically for this topic, right? The rest we are going to cover in test 2 and also final explanation, right? So that's all regarding the assignment, the assessment. Okay, hopefully all of you can complete and finish your first individual assignment, okay, which contribute for 10% on our previous topic of project cost planning. Okay, so if you have anything to ask, anything that you don't understand, okay, you may contact me, okay, regarding the assignment, right? So far, is everything good? Can you answer the assignment? All of you?
Yes, Doc.
All right. Thank you. So I hope that all of you are able to answer the question. Okay. Anything you may refer back to the lecture notes and the video recording. And if so, you still don't have a clear view, you may ask me, right? Anything regarding the previous lecture. All right, so that's all for the quick chat. Then we need to proceed to the today's topic of project ratio or project time cost trade-off. Okay. Before that, I think we just do a short recall, okay, for our project cost planning topic, which is on week 10 and also week 12, right? Before we proceed to today's subtopic. All right. Just a quick recall. Last week we have covered on project cost planning. the main items or the main topic for this project cost planning is that you need to understand if we refer back to the project cost planning part 1 and also together with the project cost planning part 2, you need to understand the type of cost, okay, the breakdown of the cost so that it is easier for you to do the calculation and to analyze the question. So if we refer back to the project cost planning part 2, you need to be able to analyze the question requirements, okay, especially in terms of the value or cost of work or cost of the project, okay. This one I have mentioned quite several times, so I think so far all of you already remember, right, regarding this one. And then the other thing quite important for the based on the question or the question requirement, you need to know which amount that need to be deducted and which amount need to be added to the calculation. This one more focus on the calculation part, right? So that once you have analyzed the question, you need to proceed with the required step, starting from the preparation of the Gantt chart, and then you will be able to prepare the detailed calculation and answer the question by analyze the calculation, right? So I think all of you can do the calculation and able to complete the previous assignment, right? So that's all for the recall or just a quick review for our previous topic. So now I will continue to this topic, which is on project creation or project time cost trade-off. Okay. Okay, so let's start with the introduction or overview for the project creation. I just refer it as project crashing since it is quite easier for us to what we call to refer and also to call it as project crashing instead of project time cost trade-off because that name is quite longer, right? Okay, so for the introduction part, this is just a definition of project crashing or project time cost trade-off. Okay. So for your information, there are several terms or names that we can refer or we can mention in order for us to what we call to refer to the project crashing. Okay. So we have time cost trade-off, we have project compression. Okay, since basically crashing and compression is quite similar in terms of how we crash and how we compress the activities. So later on, I will explain to all of you what's actually this topic all about, right? Another term or another name, we can call it as project expediting and also shortening. So all of these names or terms are quite similar and refer to the same item. Okay, so for today we just call it as project crashing. So it is easier for us to refer it. Okay. For more detailed definition, project crashing or project time cost trade-off referring to ways or how we shortening the project duration. Okay, shortening the project duration by reducing the time of one or more activities related to the project and increasing the resources. Okay, so later on, I will explain on you the relationship between the time and also the resources. Okay. Normally, as we already know that once we reduce the time, so for sure we need extra resources. Okay, so that's why there are increment or increasing in terms of the resources requirement. Okay, So we will look at on that part later on. Okay, and then we try to relate with the calculation. Okay. Because this topic also involves calculation for the project creation. Right. So far, is everything good? Can all of you catch up for this topic? Okay. So throughout the class, as usual, if you have anything to clarify, anything to ask, you may ask me directly. Okay. So we can have discussion throughout the lecture. All right. Okay, this is just another, what we call another subtopic. Supposed to be this one relates to the previous one, project cost planning. However, I would like to highlight again in terms of the total cost, since this one also related to this topic. So just a quick recall or revision. Okay. CV or contract value or project value is equal to total cost plus profit. So I think up until now, all of you already aware regarding this simple formula. So hopefully all of you can remember this one, so you can apply this in your calculation, right? Again, the breakdown for the total cost is the combination of almost 90% for the direct cost plus with the 10% of the indirect cost. So these two components are the what we call main components which contribute for the total cost, right? So this one is just straightforward, just simple and straightforward relation formula. All right, so the next one, the next subcomponent for today's class, we are going to look at on this one, relationship of time and cost. Okay, just now I have mentioned to you, to all of you, that there are relationship between time and cost. So that's why the topic is about project time cost trade-off. Okay, so the title itself, the topic title already mentioned the time cost trade-off. Okay, so these two terms, time and cost, are interrelated for the purpose of this topic. Okay, so we are going to look detail on this one. All right. So this is a conceptual graph to represent the relationship of time and cost in relation to this topic, which is project ratio. Okay. So this is another view of the time and cost relationship, which related to the project ratio, because previously we also looked at on several types of plotting for the direct and indirect cost. However, this one is quite different. Okay, another scope for the time and cost relationship, right? So what we have here is that, as usual, we have the time and cost for the main component of this relationship. Here we have cost and then we have time. All right. So, as I mentioned just now, total cost C is the combination of DC direct cost and IC, right? Okay. So we have these three lines. Okay, the green line represents the indirect cost, which is directly proportional throughout the time, or in this case, in yearly basis. Okay, for example, here we have year 1, year 2, year 3, and year 4. Okay, and the rest 5, maybe until 6 or 8. All right. So this is the yearly basis duration or time. Okay, we can see that the indirect cost is directly proportional, increasing according to the time. Okay, which is this one, about 10% of the project cost. This one is around 90%. Okay. In terms of project ratio, we can see that this blue line, which represent the direct cost, and also the black line represent the total cost. How do we come up with this one? Because as we already know that total cost consists of 90% of direct cost, so that's why these two shapes are similar. So because indirect cost is already combined to this one, green colored line combined with the blue one. So at the end we have this what we call plotting for the total cost, right? So in our case for project crashing, so for example here we have the total duration for the project is around 8 years or 8 months maybe. It is quite too long. Okay. 8 years, okay, it's okay, just take it as 8 years. Okay, we try to shorten the duration for this project. Okay, later on I will share the reasons why we need to shorten the project, right? Okay, so for example, if we reduce the time, crash the time from 8 to 6 years, we can see that here from if we take the 6 years, meaning that we have 2 years reduction, the indirect cost, direct cost, and also total cost will reduce or will decrease, right? And if we able to obtain this decrement decrease in terms of the cost, so it's quite okay for us to further crash the activities so that later on we can come out with the optimum cost. So we try to further crash or compress the activities in terms of the crashing the time. So at one point we will reach this dotted line here to represent the optimal cost. Okay. Because we need to be aware, or we need to remember that it is not simply we can simply shorten the duration, meaning that completely shorten, because it is impossible, and that one will for sure will increase again the cost, either total cost or direct cost. Okay, but it's quite different in terms of indirect cost, because indirect cost for sure will still continue to decrease, because as we already know that, for example, 4 years project as compared to 2 years project, for sure we have lower indirect cost, because we need to pay less, especially in terms of the rental, in terms of the any facilities cost. So that's why this green line represent the indirect cost keep on decreasing. However, that one not the same for the case in direct and total cost. Okay, so that's why we need to have achieve this optimal cost. Okay, once we exceed this level or this point, later on this cost may or it has tendency to increase again, right? Okay. This is the description for the previous conceptual graph, right? Okay, here we have two situations. Okay, the first one, quite a normal condition, whether we want to increase or we want to decrease. Okay, for example, this one, we try to increase the project duration or time. So in normal condition, as we know, once we increase the time, so for sure, direct cost, indirect cost, and automatically the total cost will be increased. Okay, that's the what we call normal condition for the time and cost relation. in case of project crashing, because we try to shortening, we try to compress the time, the duration to complete the project. So, as I already mentioned just now, in case of we decrease the time, we compress the time, there are still tendency that direct cost will be increased. Okay, because in normally if we try to decrease to an extreme level, if we try to compress the activities, we try to shortening the duration to an extreme level. Okay, that one require the contractor to fully utilize the resources. For example, they need extra plant and machineries, they need more manpower to complete or to construct the work. So that's why they for sure have this higher direct cost. Okay, that one we try to avoid because the main purpose for project creation is that we try to reduce the duration. However, the aim is that we focus on to achieve the optimum cost or the least cost, okay, that do not affect the total cost. If we look at here, try to decrease the time, there is tendency the direct cost to increase if we are unable to have a proper crashing, project crashing. And in terms of the indirect cost, they still have decrement. Okay. However, for the total cost, since it is directly related to direct cost, so once direct cost increase, so for sure total cost will also increase, right? Okay, so the reason for this situation is that in terms of the increment for the time, there will be efficient use of resources as time increases. This is depending on how the planner, on how the contractor allocate their resources, allocate their what we call required plant and machineries and manpower to carry out the works. Okay, in terms of the increasing or decrease the time, there will be increase of resources as time decrease. Okay. This one is the relationship of if we decrease the time to an extreme level. Okay. So for indirect cost, I already mentioned just now, it is proportional with the time. It may become less as time decrease and may increase once there is increment in terms of time, right? Similar to the total cost, because it is directly related to the direct cost. Okay. So up until now, is everything clear regarding the relationship of time and cost? Is everything okay? All right. Okay. So that's all I think for the relationship of time and cost. So we will continue to the next one. Okay, the next one is related to, it's now I already mentioned this one, reasons. Reasons or purpose of project crashing. Okay, meaning that why we need to do the project crashing or the project shortening or compression. Okay, there are several reasons to that we need to know in order for us to relate to our this topic. Okay. Sorry. Okay, so now let's continue to the next one. Okay, these are several reasons of project crashing, why we need to crash the project, why we need to do the compression in terms of the project duration. Okay, the first one is that it falls under the category of bonus or advantages because in certain situation, client requested the project to be completed ahead of actual scheduled time. Alright. So this one is based on the client requested or client request because, for example, we have a residential project. As we know, if we construct the residential area or residential housing, there are usually have several phases or stages. So, for example, we have phase 1 and phase 2 and so on. Okay, usually we will start with the phase 1, okay, or the first zone of the residential area. Okay, in certain situation, the client may request the contractor to speed up the phase 1 construction in order for them to what we call to sell the unit to the buyer or the customer. So they will proceed to the second phase so that they can proceed to the second phase. Okay, that's one condition or one situation where the client requests for the project to be completed ahead of the actual scheduled time. So if there is request like this from the client, so for sure the contractor need to crash the activities. Okay, any possible activities that can crash so that the contractor will try to proceed with the project crashing, right? Okay, so the next reason is that regarding the penalties. Usually penalties is related to the delay, right? Once there are delay in terms of the project progress, in terms of the activities, so most of the time, the contractor will bear the penalty. Okay. Delay of early activities force the contractor to reduce the remaining time to meet the actual scheduled time. Okay, for example, throughout the progress of work, the contractor should meet 50% of the project completion as their current progress. However, they are still behind the schedule for about 20%. Maybe the current progress for their works is only 30%. So in that case of delay, okay, if we relate back to our pandemic, okay, for example, in COVID-19 cases, okay, we can see that so many projects, so many construction activities which are forced to be suspended or postponed, okay, due to the condition. So that situation require the project time or project duration to be crashed so that at the end they can come out or they can complete the project in order to meet the actual schedule time. Okay, so penalties will force or will allow the contractor to proceed with the project finishing. Okay, so that's the reasons. Another reasons is related to the resources. Okay. Some of the contractors, especially for the big company, okay, they usually have a few what we call few projects at certain at the same time. Okay, so they need to create the resources for them to move to the other side or to the other project. So that situation or the condition require them to proceed with the project crashing of the existing or the current project so that they can speed up or they can proceed to the new project. Okay, so they need to use the resources. That one will require them to shortening or compress the current activities so that they can easily proceed to the next project with their resources. Right? Okay. Another reasons relates to the seasonal condition or consideration, especially in terms of the adverse weather condition. Okay. In local perspective, okay, for example, in Malaysia, we have a certain weather condition, especially at the end of the year. We have heavy raining or flooding. Okay. Based on the forecasting, if the contractor already forecast of the potential adverse weather condition, so in order for them to speed up the project progress, so they try to compress the project. They try to prepare the project ratio, okay, in reducing or shortening the duration, right? Okay, another thing or another reason for project crashing related to the impacts. Okay, impacts are usually related to the error in purchasing excessive materials. Okay, this one also related to the resources, especially for the materials, meaning that at certain time, the contractor have extra or excessive material available at site. So in order for them to avoid wastage, negative cash flow, they need to reduce the time in order for them to utilize all the resources, especially the materials. Okay. All right. So these 5 reasons are the main reasons that I have simplified here. I have summarized here. So maybe we have another sub-reasons related to this that we may refer to, and we may explore more on this. Okay. All right. So that's the reasons for why we need to do the project crashing. Now we will proceed to the ways to shorten the project time. So far, is everyone still okay? All of you? We have Suryati. So the total, all right. So right now we have all of you already here. Because some of you have more than one class in one subject for my part, right? Later on we will have another class. Okay. Okay, so the next one, we try to cover on ways to shorten the project time. So in order for us to shorten the project time or the duration for the project, we need to either sequencing activities or accelerating the activities. Okay. Usually resequencing activities is less what we call implemented, because in actual practice, okay, because there are various type of activities, so it is not that simple for us to resequence the activities. So we can, if we want to do so, we can focus on any constraint which helps to eliminate the coordination problems. Okay, we try to sequence the activities if we try to improve the coordination problems. Okay. However, it may unnecessarily delay the project completion. So any constraint, any factors that affect the project should be avoided unless they are essential, okay, in terms of the constraint. So, okay, that one for the sequencing, how we rearrange the activities. And the other ways is that to accelerating the activities. Okay, so this one we are going to focus on how we accelerate, how we fasten the activities duration. Okay, in compressing and also in shortening its duration. Most of the time, schedule cost is usually optimum or minimum. Okay, and it will increase the cost, especially the total cost. Okay, so we need to accelerate. We need to properly select the activities that has potential to be compressed. So that's the main what we call the main skill or the main responsibility fall under project planner. So they need to be creative. Okay, they need to know how to accelerate the activities, which activities to be selected, which activity to be compressed in order for them to have total duration with shorter time for the construction, right? And then we need to remember that it is really feasible to completely crash the activities. Okay, because not all the activities can be totally crash, completely crash. So we need to properly select the activities, and it is depending on our own decision which activities to be crashed because as I mentioned previously, time will be related to the cost. Okay, so our decision to choose an activities to be crashed will lead to the effect on the cost for that specific activities, right? So we try to balance on the selection, which activity is the most appropriate, or at the end it will give the optimum cost for us to proceed with the crashing. Okay. Another thing is that shorten the project at the least cost. Okay, later on I will highlight again on this one because we try to shorten the project, shorten the duration at the optimum or least cost that we can achieve, right? Because we try to balance these factors, time and cost. So at the end, the contractor will not bear damages or will not bear any loss for the project. Okay. So how we want to crash the activities actually? There are several options related to the how we are going to conduct the crashing for the activities. Okay, the first one related to the manpower or labor, which is the first end of the 5M previously I already shared with all of you, 5M for the project resources. Okay, this one, manpower or labor. So in order for the contractor or the planner to decide to crash the activities, so meaning that they require extra manpower for each activity. And most of the time, they need to have multiple working shifts. Okay, maybe they need to have extra working shift in order for them to complete specific construction activities. Okay, they need to increase more working shift, they need to have extra working hours or days here, which is related to the labor itself, the manpower. Okay. The other thing related to the plant and machineries. Okay, in order for us to decide to come out with the project crashing, so that in other words, we need the larger plant and machinery with higher CP or the productivity output. Okay, so meaning that the once we compress the time, okay, for example, if we take what we call tower crane or mobile crane, instead of using one or two for the project, maybe we need another or we need double quantities of the existing one. Maybe we need more okay, for that for us to have a higher output for each of the related activities. So that's why there will be additional equipment or plant and machineries needed for the certain tasks or certain activities, right? And then in terms of the material itself, okay, and other resources for the project, maybe sometimes in order for us to fasten the project, in order for us to deliver the project in shorter duration, we need or we require more costly material but more quickly to be installed. For example, instead of conventional construction, okay, we try to purchase the precast component, which is IBS component, for the structure to be built up. Okay, so that's the example on how we want to crash the activities and what are actually the requirement in terms, especially in terms of the resources related to the manpower, related to the machinery, and also material. Okay, that's the situation. Okay, so the next one we try to cover. I think the next one with some what we call example, okay, on how we want to shorten the project time. So here I would like to relate with the productivity of the labor related to the cost and also to the time of each activities. Okay. Okay, as for now, okay, here we have simple example, okay, with provided with the estimated daily production for each of the crew site. Okay, the task or activities is for installation of metal siding. Okay, these are the estimated daily production in meter square, in meter area, and the size of the crew, meaning that the size of the uh, gang. Here we have several options A up until D. Okay, each of group, okay, the crew size or group size consists of several types of labor, and provided here with the cost for each of the machine equipment and also labor wages, right? Okay, so based on total area of 7,700 meters square, what is the duration for installing the metal siding? Okay, for example, if we proceed with the first option, which is the crew size A or gang size A, we take this total area and then divide it with the estimated daily production, so that we can come up with the actual the expected duration for these activities. Okay, so 7700 divided by 120, okay, for the first case A. At the end, we have this duration for these activities of installation metal siding, which is 65 days. So this is the duration if we choose or we go for the first screw size, which is screw size A. Okay. Then, if we proceed, okay, this table, summarize the duration, duration and also cost for each of the crew size A until D. Okay, so based on the previous calculation, okay, this one we just proceed to the rest of the crew size. At the end, we will come up with this one. However, we use the run-off amount or value. Okay, so for crew size A, the total duration will be 65 days. And this is the rest of the total duration if we go for B, C, and D. Okay. And on our right side here, we have the cost, total cost for each of the option. Okay, if we calculate for each of these crew size, okay, for example, let's say we have crew size A, the if we select this one, the total duration will be 65 days. And then the total cost will be 23,660. Okay. And then we try to calculate or try to proceed to the next again, okay, before we do the final selection. Okay, as we can see here that gang B or crew size B recorded the what we call longest activity duration here, 51 days, with the least cost or the optimum cost, with the 22,644 thousand here. Okay, so meaning that even though here just now we have for the group B, we have one scaffolding, 2 laborers, 2 carpenters, 1 carpenter foreman. So here we have another additional carpenters here as compared to the crew size A. So meaning that even though we increase the number of workers here, there's still a chance for us to have this lower total cost. So we need to know how to analyze, we need to try calculate, okay, try to select the best option. In this situation, this is the best option, which is crew size B, because we have shorter duration to complete the work with the least cost here. If we try to translate in this graph plotting, so we can see that the second option, this one is B. So A, B, and sorry, B, C, and D. Right. That's right. Okay, so just now I have shared with all of you the conceptual graph for the time and cost. So we can see that there is inverted curve here, mostly likely inverted here. Okay, so if we this is the first option with 65 days here with this total cost to 23,000 K plus here. If we try to analyze the other gang, the other crew size, we are able to reach this one, meaning that we have optimum line here with the least time and also cost for construct the work, installing the metal siding. And if we further analyze or evaluate, the cost is increasing. So based on all this option, B is the best option because with the least cost and time to construct the work. Okay. So can all of you understand this? Or am I going to pass to explain this to all of you? Okay.
Doctor.
All right. Okay, so hopefully all of you already got clear with this one. If you have anything to ask, you may do so. Okay, the next one. Okay. So I think because the next one will be subtopic for us to look at on the calculation part. So before that, I think can we have short break about 10 minutes? Is it okay? Right. So we will continue at 11 a.m. Right? Within maybe about 9 or 10 minutes. Okay. So see you later. Of you already here, so that we can continue the class. Right. Okay. So the next one we are going to look at on the next subtopic, which is so far we have covered 5 items. Right, reasons with, and then the next one before we proceed with the example of the detailed calculation, we need to know the assumption of project crashing. Okay, there are several related assumptions for us to consider before we do the calculation. Okay. So these are the assumptions that we need to consider in order for us to do the crashing or the shortening of the project. Okay, the first one, we need to know that we need to know on the cost load, right? So again, this is the relationship between the cost and the time, right? So later we will need to calculate what actually the cost load for each of the project or the activities. Right. For the cost load, there are four main components fall under this cost loop. The first one, we have crash cost, normal cost, NC, CD for crash duration, and also ND for normal duration. So these are the four components for the cost loop that we need to identify so that we can calculate the cost loop. So again, there is cost load. We consider the linear relationship of the activity duration, meaning that the time and the direct cost. Okay. So the first one is the plotting on the cost load, right? So in actual practice or in actual condition, the cost load will be form like this shape, the blue colored line. However, for the purpose of our for academic purpose and for our calculation, we just simply consider this straight line for the cost load, right? Because the actual condition out there, we have more complicated situation or condition because there are too many activities involved in one project. So for our purpose, we just consider simple project or simple activities. So that's why we can refer to this straightforward for the cost load calculation because it is the most likely the same because to this close approximation, right? Okay, the next assumption we need to remember the equation of the cost load. So the second item related to the first one, okay, this is the equation for the cost load. Okay, on the upper region we have crash cost. We need to consider the crash cost subtracted with the normal cost, and then these two will be divided with the normal duration minus the crash duration. So on the upper part, we have cost element here and divided with the duration or time. Okay. So this is a simple equation for calculating the cost load. So hopefully all of us can remember this one. Okay, so it is easier for you to apply in the calculation. Alright. So another assumption is that we need to remember that some activities can be crashed or shortened while some of them cannot, right? So this one we can relate later on with our calculation. We can see which activities actually can be potentially to be crashed and which activity that quite impossible for us to crash, especially the one with the critical path, right? We need to properly identify critical path so that we can properly select the activities within that critical path. Okay. The next one, we proceed with the example on how we want to calculate the cost load. Right. So based on this simple example, suppose activity A has a normal duration. So this one will be ending of 10 days. and can be shortened to minimum limit of 6 days. So this one will be crash duration. Crash duration. Right. The cost of completing activity A is 6,000 with the normal duration of 10 days. Okay, so this one is normal cost and C. But if it's to be completed within 4 days. Okay, so this is the allowable duration that or the limit that we can crash. So this one crash duration meaning that the new duration is 4 days and the cost will be 10,000. So what we want to know is that the cost look for this activity A. So if we plot the graph, here we have the original duration of 10 days. This one is duration. And the crash one will be 4 days. And here we have 6 days shortening. 6 days. And then for the cost, here we have 10,000. And then this as, sorry, 6 and 10,000 and 6K. So cost load will give you 10. So just apply the formula. Okay, put all the formula crash cost minus the normal cost. Okay, like this one, crash cost minus the normal cost divided with the normal duration minus with the crash duration. So 10,000 will be subtracted to the 6,000 divided with the 10 days minus 4 days. At the end, we have this cost load. So, what's actually this cost load refers to, right? So, 667 ringgit Malaysia per day is the cost, daily cost that the contractor need to spend in order to crash the duration of activity. So, this is the cost that they need to allocate in order for them to shorten the duration of activity. Right? So that's the basis for this cost load. Right? Okay, so that's the example for cost load before we proceed to the next calculation on how to crash the project, on how to crash the duration for the project. Okay, so far so good. So we proceed. Okay. All right. So thank you for your response. And I hope all of you are still here. Okay. For this class. All right. Okay. So this is the last component for our today's topic, which is we will focus on the steps of project crashing, and at the end I will show you the example for the project crashing. Okay, so in overall there are several steps involved that we need to consider in order for us to prepare the shortening or prepare the crashing for the project. Okay, so the first item is related to the network diagram. The network diagram, why we need this one? Because we need to determine the normal duration, the total duration for the project to be completed, and then we can identify the critical path, right? So there are two elements, or there are two items that we require for us based on the network diagram, and then we can proceed with the calculation of cost load. This is the first one. The second one, cost load. So based on the given information, we can calculate the cost load using the equation just now. Okay, CC minus NC divided by ND normal duration minus by crash duration. So later on you may apply this equation for cost loop calculation. And the third one, once we have done with this two, we proceed to the next step, which is crashing the activities. This is the main part, okay, when in crashing the activities or selecting the which activity to be crashed or to be shortened, we need to select a critical activity, the main criteria, critical activity or critical path with least cost loop. So these two are our priority. Okay, the first priority is critical activity, and then the second priority is least cost loop, because we want to crash the activities or shorten the activities with the final or optimum cost. Okay, final least cost or optimum cost. So that's why we need to properly consider this one in selecting the activities. And then once we crash the activities, most of the time we can do several crashing or several steps of crashing. At the end, we can come out with the optimum cost. So, mean that this one we have crash activities for one time, and then we can repeat. Okay, we can look at for the other tendency, for the other possibility, for us to proceed with the project crashing. So we can recheck the activity. Okay, usually once we have crashed the normal condition of the activity, there will appear new formation or second or maybe the third critical path. Okay, so there will be new formation of critical path, so we can recheck it. And then once we do the crashing, for sure we need to determine and calculate the new direct cost. Okay. Based on what we have done, we need to calculate the direct cost and at the end also the indirect cost. Right? So indirect cost, we need to do deduction. Deduct the indirect cost for the new total cost. Okay, if we remember back, I just shared earlier the relationship between direct cost, indirect cost, and also total cost for the purpose of project crashing. Once what we call we crash the time, okay, there will be sometimes most of the time direct cost will be increased. However, indirect cost still decreasing. Okay, because it is directly proportional to time. Okay, and the cost will increase. Okay, so that one you can refer back. That's the relationship between time and cost. Okay, so now we proceed with the sample question for the project crashing. Okay, this example one shows the project before crashing. Okay, as we can see here that the numbering here, the 1, 2, and 3 is basically refer back to the step that I mentioned just now. This one network diagram. So we need to prepare this network diagram, and then the two cost load. Okay, this is the cost load. Okay, how much is the cost per day if we crash the duration, and then number 3, the critical activities. Okay, for this case, if we look at back, this is task A will be the critical activities because it has the longest duration here, for 10 days. Okay, so based on this networking diagram, we have information of total duration of the project, and then different activities A, B, and C. Okay, the duration for each of the activities. Okay, each of the activities. 10, 9, and 8. And this one is the maximum crash duration, and then this is the cost loop, right? All right. So for this case, the condition of the network diagram or the activities before the project crashing, the normal cost or total cost is 5,000 here. This is based on this example, right? And then next step is that we try to crash this activity, okay, this project. So as I mentioned just now, based on this, we select the critical activity with least cost loop. All right. However, we take the first priority. This is the critical critical activity. So we try to compress this activity first. That's it. Okay. So the actual duration is that 10 days. If we try to compress for 1 day, you can see the effect. Okay. So for example, 10 days, now it become 9 days. Okay. So we also need to deduct here 1 day, deduct 2 days, and then similar to this one. Okay, 9 days also. All right. So once we compress this one, we can see that there are new formation of critical activities. So now task B is become critical, similar to task A, because both of these activities consist of 9 days of completion, activities completion duration. Okay, so this is item number 4. This one, we check activity, look for the formation of second or third critical path. So this one will be the second critical path right now. Okay, then step number 5, we need to calculate the new total cost, direct cost, new direct cost. Okay, so just now we have crash activity A or task A for 1 day. So what's the effect on the cost? So task A, it's already mentioned that the cost load per day is 100. So we need to add another additional 100 to the total cost. So this one will be 5,100. Okay. So this is the effect of this project crashing task A for 1 day. And then we are trying to look at for more option. We try to evaluate. Okay, if we do the further crashing, what's the effect on the cost? Right. So then we proceed with project after crashing task A and task B. That 2 days. All right. So now A and B are critical activities. So we focusing on this. So we left behind the task C. We're just focusing A and B first. Okay. So for 2 days, now there will be another 1 day here and another 1 day for task B. So task A will be 8 days because we have 1 more day's deduction, and similar to here, this one also deduct by 1 day. Right. So the total will be 8 days. It's similar to here. Remember to do the deduction of the total duration. And as we can see, now task C also become critical because all of these are 8 days here. So it should be like here. So become critical. And now we need to recalculate again because you need to know that this project crashing task require you to do the repetitive work because you need to crash, then calculate the cost, then you redo the crashing part and then recalculate again, okay, up until you have the optimum one, the optimum cost. All right. So What's the effect of this second condition of the crashing? So for the cumulative crashing cost, we have another deduction. Previously, we have 100 for the previous crashing activities of activity A, and then we have these two additional one to represent another crashing here. It is it will be 100, another 100 reduction addition here, and then 75 days another addition for task B. So now the total additional amount is 275 to be added with the existing total cost. So this is the current total cost, new total cost. Similarly, this is if we try to further crash the activities, further crash the task. Okay, for example, if we go for 3 days, okay, and then we consider all of these activities. Okay, so now 1 day for each activity, task A minus 1 day, task B, and also similar goes to task C. So again, all of these are now critical activities, and just what we call repeat the same or similar calculation as long as you consider how many days that you have crashed and what are the costs for the cost loop, right? Here we can see that there are no more balance for crash duration available for task A because in that task A we are really crash. Okay, we call the activities. Okay, this is the meaning that it reach the limit, right? So this is the most possible duration, which is 7 days, right? As compared to task B, we have 1 more day left, and then task C, we have day left, right? So just recalculate this one, and this is from the previous one to 75 plus with the another additional amount charged for the crashing activities, 100 for activity A, 75 for activity B, and 50 for activity C. So at the end, you come out with this one. Alright. So based on the previous calculation, we try to make it in this form, in this plotting graph. However, it is not compulsory for you to prepare this graph. This is just for the purpose on how we want to look at again, we want to evaluate again in terms of the summary, okay? So that it is easier for us to look the whole condition of the project crashing. Okay, this is the original one, 5,000K for 10 days activities, okay, 10 days project duration. And then if we crash for 1 day, which is become 9 days, the cost is increasing actually 5,100. Okay, if we further crash, we can see that there is increment here. So all of these we call depending on the decision by the contractor, decision by the planner on selecting which option they would like to proceed. Okay. If we have, if they have more resources, they are capable to what we call to allocate more budget for 7 days working duration, then they can use this one. So all of this depending on their decision, depending on their ability in terms of the resources, and also the most important thing in terms of their cost. So that's this is the main purpose of project crashing. And once we come out with this one, we can foresee, we can predict what is the effect for their cost. Okay. The effect in terms of time, and also one most important thing is that on the cost itself, right? Okay. Okay, before we proceed to example 2, is everything clear for example 1? Okay, can you understand that? Okay, all right. So I will proceed to the example 1. This one. We can see here that this is the item number 6 just now related to indirect cost, because most of the time, most of the situation, the actual situation give you the indirect cost amount in terms of assumption, okay, for the project. Okay, for this example 2, we can assume that the indirect cost of the project is 50 days, 50 per days, right? Okay, so the information given here is that the types of the activities, duration, both normal and crash duration with the cost. Similarly, we have normal and crash cost. And here we have some marking for critical path activities. So B, C, and E will be the critical activities. So based on this, it is given that what we call, based on this, we need to calculate this one, cost flow. Okay, just use the previous equation for the cost flow calculation, okay, based on this value, and D, okay, and C, okay, crash duration CB. CB, this one is NC, CC. Alright, so based on the given equation, previous equation, you just need to calculate the cost flow here. Okay, for each of the activities. So that later on, all of this information will be included in your network diagram. Okay, it's already mentioned that critical path consists of B, C, D, and activities. And then project duration is, for this case, is 140 days. All right. So based on this information, this is the network diagram for the example 2. Okay, we can see here that just now, activity B, C, D, and E are the activities for critical path. So I have highlighted here with this red arrow, okay, to represent critical activities. Okay, and up here we have the activity A with the 120 days for the duration. Activity A, this one. And then the normal, the normal duration for this. Okay, the available duration to be crashed is 20. B5 and so on, C10 and also DF also 10. So how do we get this information? We just do the deduction here. 120 minus 100, you get 20. So this one, 5, 20, 10, okay, and so on, right? Okay, so another thing is that this one we have that. Here we have 15, right? If we do the deduction here. Okay, so this is the total duration for this project. And for the normal condition, we need to first calculate the total cost. Okay, because for this situation or for this example 2, it is given the information for indirect cost. So we need to calculate the combination of direct cost with the indirect cost, so that we need to know the total cost. Okay, so direct cost based on the previous calculation, this one, you need to consider this one, normal cost for the direct cost. This one for direct cost only. Okay, not include yet the indirect cost. So you have for 48,300 for DC direct cost plus with the previously it is given that the indirect cost I see you can assume is about 50 ringgit per day. Then you need to multiply with the total duration. So 50 ringgit for the total project duration in normal condition before we do any crashing. This is the total cost, right? Okay. Then we proceed with the next one. Okay. Now, how do we select this one first? Back again, if we refer back to the criteria to proceed with the project crashing, we need to focus on the first critical path. The second one is any activity with the least cost load. Okay. So if we compare here that critical path, least cost load. All right. So here activity activity B we have 200, this one 600, this one 60, and the other one is 120. So that's why we go for activity D first as our first activity for the question. And then for this case, we try to do the complete crash for this allowable duration. Okay, we try to deduct 10 days here, and the new duration will be 20. Okay, 20, we need to what we call calculate again, we need to update the latest duration for each of the activities. And at the end, we can see here that now the activity, the total duration will be 130 here because there are 10 days deduction in order for us to crash activity days for activity D for 10 days. Okay, so now activity F become critical because the duration is 60, which is now the same with the this one activity. Sorry, the same with this one. Okay. Okay. So for the calculation, once we do the crashing, we proceed with the calculation of total cost. Previously, we have this one for the normal condition, and then we need to consider the direct cost imposed on this crashing of activities, activity D. Okay, the cost load is 60, and we have to do the crash for 10 days. So that's why we need time or multiple with 10 days here. Okay, so the amount will be 55,900. 55,900,000 here. Then we need to do the deduction, right? Because we need to bear in mind that we need to deduct the cost for indirect costs. Once we crash the activities, the indirect cost will be decreased. Okay, will be lower. So that's why we need to consider this deduction here. 50 ringgit per day multiply with how many days that we crash. So in this case, it is 10 days. Then the new one, the new total cost will be this one, 55,400. Okay, this is the situation when we crash the activity. Okay, all right. So next, we will try to look at again what we call the potential activities that can be crashed. So now, if we proceed with, or we decide to crash D, there's now D, and now we have E. Okay, we try to crash activity. Why we choose E? Because if we compare here, B, C, and F, E have the has the lowest cost loop here, 120. Because D just now cannot be further crashed because it's already 0 here. Okay, so we look for the adoption for the other tasks or activities. Yes, so we go for E. E also we try to crash for another 10 days. Right? 10 days here. Then this is completely utilized here because there are no more values, no more days that can be crashed. Okay. And now the total duration now become 120. So A also now become critical activity. Okay. Again, once we have crash the duration, select the related activities that we want to crash, we need to calculate this one, total use, right? So 120 for activity, crashing for activity A for 10 days, we need to do deduction. We carry forward this amount, 55,400 to the next one, plus with the current crashing cost, and again need to remember that need to deduct here for the indirect cost, and we able to obtain this new total cost, right? So that's why I mentioned just now this project crashing activities is actually repetitive work. Okay, we need to analyze which activity is potentially to be crashed, and then we need to recalculate again the total cost, right? And then now we put the crash, okay, consider D, E, and also AB, because now all of these, what we call all of these activities become critical path. So it's depending on our what we call on our decision which activity try to put the crash. Okay, which activity that we want to select. So in this case, another crashing on activity A and also B for 5 days. 5 days. 5 days crashing. So if there is crashing A for 5 days, this one become 50, and this one fully utilized, which is also 5 days. So now become 0. And then the new total duration is 115. Instead of normal condition, we have 140. So we'll crash here, crashing here. And then, why we choose A and B for this case? Refer back to this cost loop. The cost loop here is 100, and this one is 200, which is lower than this one, F 300, and also C 600. That's the hint or the criteria that can help you to select which activity that's suitable to be crashed. Okay, so again, calculate back this this total cost. Similarly, just take this one, carry forward, then do plus with the another new what we call new direct cost. Okay, cost loop relation. 100 times by 5 for this one, activity A, 200 cost loop, 5 days for activity B. Then you need to deduct with the direct cost here. 50 ringgit for 5 days. Because the total duration that we crash here is 5 more days. So this is the new total cost. Up until now, I think that's all, or do we have? Okay, we have another one. So all of this depending on your decision. So for the purpose of project crashing, there is there is some what we call range of the values that acceptable for us to proceed. Okay, meaning that maybe it varies among us. Okay, maybe I do the crashing with this amount. Okay, some of you may have quite different amount, maybe 6400. So depending on which activities that we select. So there is no, meaning that there is no exact amount for all of us. Okay. So for the purpose of assignment or for the purpose of maybe final exam, as long as you have you have for the purpose of assignment, as long as your cost or your amount is still acceptable, then I can accept that. Okay, for the purpose of final exam, you don't need to worry because in the question it's already stated that which activity that need to be crashed. Okay, for example, for the whole example 2, it's already mentioned that you only need to crash activity and only. So at the end, all of us can come up with the same amount because we have crashed the same activities. Okay. So that one for the purpose of final exam. This one is the actual condition on what we call project crashing looks like. Okay. So we can try an error. Okay, we can try to crash any potential activities based on our own creativity. Okay, as long as at the end we can target for the optimum cost, right? So just continue for this example. Just continue crashing the A, C, and F again, and then for another 5 days. Okay. And this is the total one, the total new total cost, new total cost. Okay, similarly, there will be additional crashing here, 5 more days. Okay. It looks like this one is never ending calculation. However, it's depending on our own what we call own creativity and own ability. Okay, depending on the available resources and also cost capability of each of the contractor. All right. So I think that's all. Okay. At the end, this is the summary of the project crashing. Okay, so we can see here that based on this what we call graph plotting, cost versus time for the project crashing purpose. This is the normal condition where the project should be delivered within this 140 days for the normal or actual condition with this cost, 55,300. Okay, if we do the first first condition or first situation of crashing, which is we select the activity D, if I not mistake, okay, that's one D. Okay. So this is the effect of the cost. There is only 100 additional amount. It is increasing. However, it is a minor increment. 55,400. Additional 100 here. And then if we further crash, we can see that the cost is increasing. So that's why I mentioned just now, it's depending on the contractor themselves, which option they want to select. Either they want to stop here, or if they are capable, they can go for this one. Okay, so they can construct or deliver the work within this duration, 105 days. Okay, So I think that's all, right, for today for our topic, project crashing, or supposed to be the official name, project time cost rate off. Okay, so it's easier for us to just mention project crashing because it's just similar terms, refer to the similar, the same item. Okay. All right. So far, is there any question before all of you scan your attendance? Is everything clear? All right. Okay. So later on, again, I will provide the individual assignment. This one maybe individual assignment 3, because 2 and 3 will be for my part, individual assignment. Okay, similarly, I will put in the e-learning together with these lecture materials. Okay, hopefully for our previous topic on project cost planning, you can complete your individual assignment too and submit the assignment to meet the deadline. If I'm not mistaken, that one will be on 15, right? 15 of January. Okay, so if we all of you have any nothing to discuss or nothing to ask before we end our class, please scan your attendance and report. Okay. So once you scan your attendance, we can dismiss. So that's all for today. Thank you for your participation and hope to see you next week. Assalamualaikum and good day.